Hello, my name is Uzair Ahmed Khan. Today I'm going to be talking about PalmShield, an AI integrated framework for identifying date palm tree health. In this presentation, we will be talking about the problem and how it impacts us all. We will be talking about the solution to our problem and an on-field testing of our solution. So to begin with, palm trees. They are a multi-billion-dollar industry and there are 40 million of them in the UAE alone. They are important to the agriculture, to the food supply and the culture of the UAE. They are also a great asset in our fight against global warming as they can absorb up to 200 kilograms of carbon dioxide per year. And once these date palm trees get sick, an average farmer has to have a lot of time and a lot of expertise in identifying these diseases. And once the identification is too late, farmers have to resort to spraying pesticides which ruin the ground underneath the tree, and they themselves cause a lot of carbon dioxide to manufacture them. So our solution is to automate the process of identifying the diseases in date palm trees. To do this, we trained an AI network with a dataset of over 3,000 images that consist over 8 disease classes, 600 raw images that were taken in real date palm farms in Oman. So how does our solution work? A farmer takes a picture of a date palm tree with his phone, and our solution computes an identification of the disease for him. And with that, he can get a recommendation on what to do next, as well as see other insights like how his overall farm is doing.
Assalamu alaikum. My name is Abdulhad Muhammad, and I will talk about AI, how we use AI to train each model. Assalamu alaikum. My name is Abdulhad Muhammad, and I will talk about how we use AI to train our models. Assalamu alaikum. My name is Abdulhad Muhammad. Assalamu alaikum. My name is Abdulhad Muhammad, and I will talk about how we use AI to train our models and also the results. So we use 3 deep learning models: Custom CNN, Recent 50, and EfficientNet B0. The best one was EfficientNet. We got 90.8%. Also we use Deep Ensemble, which mix between ResNet 50 and EfficientNet. This is without training. For the unit, we use it to determine the position of the diseases. Okay, we got 97.3%. Also use class-weighted loss to get more balanced data, and we use data augmentation to increase number of samples and to make it 1,500 per class. And for example, for the leaf spot, it was just 69, I think. So when we use data augmentation, we increase it to make it 1,500 to make like a new or copy images. Also use 3-phase gradual freezing for the EfficientNet to extract more features. This is the results for each model with the accuracy, precision, and F1 score. And yes, EfficientNet, it was the best model. And also we faced some difficulties to classify magnesium deficiency and leaf spots because they have some similarities. Also there were confusion between potassium deficiency and fusarium wilt. For the discussion and limitations, we use transfer learning, which is Recent 50, and EfficientNet. Why? Because they have already trained on ImageNet dataset. So they got trained already, and they extract features, for example, the edges, circles, and so on. And comparing between compound scaling and depth scaling, EfficientNet, it has 5.3 million parameters, which outperforms the Recent 50, 25.6 million parameters by 2.2%. So, and we use ensemble complementarity, which it is like without additional training. We got 92.3%. Now limitations, we know that because leaf spots, it has only 69 original images. So even when we use data augmentation, it is just copied or duplicated images to make it 1,500 using data augmentation. Also for the black scorch and paralotteria. Okay, so more field data is the priority, same as the other classes. and related work and research gap. So most of them, they just use 3 classes. Just one of them, like the second one, they use 9 classes, but even it is without unit of to determine the position. So these are the features. It is easy to use offline, and you can see also statistics about the about your farm. And also it is satisfy the sustainability, and you can just create a QR code for each palm tree, and you can manage your farm by clicking on this button. Okay, this button, the farm management, you can see all your trees in that farm. Also, you can either use quick scan tree or scan leaf. So you can take scan for the whole tree or per each leaf. And yes, that's it. You will get also when you see your farm, you can see percentage of healthy per each tree. And now you can see real life demo with my friend Hussein to show you details about the app.
Assalamu alaikum and welcome to our real life demonstration for the app working in the real time. Okay, so we have here 3 trees as a representation for our farm currently. This is our app, PalmShield. We can open it. So the idea is design language fit the natural theme for demonstration that this is an environmental app. Okay, so we have here total CO2 saved 36.4 tons. Okay, this will update with our farm expanding and growing for better health and better CO2 saving. Our app message is your care saves lives and the environment. So here we have the farm management tab. In the farm management tab, we will open it. We will open our farm, which is this specific 3 tree place. We have those 2 trees which have been scanned. The only tree left is this tree, which we will use for demonstration purposes. Okay, so we have this QR code. We will scan the app. This QR code contains the tree name and the coordinates for the tree, so it can be saved in the correct location, in this specific location for this tree. So we can open the QR code scanner. It has been scanned. Now, for our model to understand that this tree is healthy or not, we can take a photo of the whole tree. Okay, then it will make the computations. As we can see, this tree is not healthy at all. This is mainly furazim wilt disease. As we can see here, it is really diseased. Okay, so our app is working correctly. We can save it now. Save the capture. When we save the capture, a new tree has appeared here, and as we can see, we can open it to review our old scanning. As we can see, everything is red, which means that the whole tree is infected. And here we have an expert advice for normal use case. We can know what should we do with this specific disease. So now we are in a new location. As we can see, this is an almost healthy tree. I will try to scan it, a quick scan. Instead of scanning a whole farm, we have a button called quick scan tree. We can scan just one tree. So we can scan it and see what it will give us. This is almost healthy. It has some spots where it is yellow, but mostly it's healthy. So now the app is making the decision. As we can see, it is 68.2% healthy. Okay, and it will show us where it is healthy, where it is not healthy. And if we go inside the tree, we can see that yes, a couple of spots is not healthy, but mostly, especially on top, is healthy. And in the app, it is showing the same results. Finally, I want to talk about our aim with this project. Our project is designed to be deployed on drones, robots. So in a farm, we can make a self-driving robot that will take shots from all the trees, okay, and then save them in the app. And as a customer or as a farm owner, you will see your whole farm, the percentage. For example, here our Al Jahili farm is very low, the percentage of the health in the farm and that stuff, so you can monitor it better and save the environment in a good way. And that was it for our PalmShield app done by Abu Dhabi University students.